Hello friends, this video on alcohol, phenol and ether part 17 is brought to you by examfear.com. No more fear from exam. Now we'll take some examples on alcohol. So we have to give the mechanism for this reaction. Let's try. This is my reactant. Let me treat this. CH3, CCOH, Correct. The first thing is you have protonation H+. So oxygen has lone pair of electrons. It will attract this H+ toward itself. It will be a fast reaction. This is, we have seen a couple of times, right? This is the only possible place where H+ can attack. Now it will be OH, H. And since oxygen has given electron to H, oxygen will get a positive charge. Correct? And this will be CH3. Now H2O is a good leaving group, but it will happen slowly. Slowly it will get out of this. It's a good leaving group actually. So it will form CH3. So this bond actually will break. This bond breaks, oxygen gets a negative charge, this carbon gets a positive charge. Oxygen gets a negative charge, it already had positive charge, it is neutralized now, right? So carbon will now get a positive charge here. Sorry, this is CH3, and here CH3. Now if you see, this is a 2-degree carbocation, right? There is a high chance that if we remove one hydrogen from here and keep it here, it becomes a 3-degree carbocation, right? I will show you. So this hydrogen somehow comes here, it becomes 2-degree carbocation, right? This bond breaks and this hydrogen becomes H. Sorry, this is like this here. Yeah, this is like this, and this H- will come and join this, and this carbon will get a positive charge because this bond is breaking in this direction. So what you get is C+. Why is happening? Because with this you get a more stable carbocation, right? More stable carbocation. So there's a rearrangement that happens. And now on this I have a Br minus, right? Because I had HBr. So Br minus will attack this. So you get CH3, CBr, CH2, CH2, CH3. So if you see, this exactly matches with this. Correct? The next reaction is dehydration of ethanol to yield ethene. So acid dehydration of ethanol to gives ethene. So I have ethanol. From this I want ethene. I want to give the reaction mechanism. I think we have done this, so I'll show you. CH3, CH2, OH. The first thing that will happen is oxygen has lone pair. This is plus. It will attract this guy, so it becomes CH3, CHHO, HH. Since oxygen gives electron, oxygen gets a positive charge, and this OH2 plus is a good leaving group, right? So this is minus H2, but this is slow. So you get, since this bond breaks, right? This bond breaks in this fashion, and this bond breaks, and this gets negative, this gets positive, this negative positive combined become neutral, and this is positive now. So this carbon is positive, H and H. This is a carbocation form. Correct? Now carbocation is formed. What is the next? Now if you see, there is no Cl minus or Br minus to attack here, right? It's all acid dehydration. So the only option is you remove one more H+, right, to make it stable. See, either add something which has negative charge or remove H+ to make it stable. So since there is no such X minus here, what will happen is it will remove H. So from where it will remove H? So I will show you. So if you see inferior by H3, let me draw in this fashion, right? So if it removes from this carbon, right, this H is gone, it will get a negative charge, and negative and positive can form a bond, right? So if you see, if you remove any of this hydrogen, this bond will break in this fashion. This gets negative charge, this gets positive charge, positive H goes off, right? And then positive and negative charge will form a bond. This is what it forms, and this is my ethene. Correct? This is called my acid dehydration. So if you see, whatever acid you are forming here will be again used here. It's the same actually. So you are using H plus and then you are releasing the H plus. So that way it is maintained. Correct? So let's see mechanism for hydration of ethene to give ethanol. So I have ethene, and from this I have to give, I add H2O, I have to give ethanol, right? So we have to synthesize the following alcohols from proper alkenes. So if you see here, what we can do here is, this is my alkene and I have to form alcohol. So what I can do is I can take this compound actually. If I add H plus in presence of water, I'll get this. Correct? Why? Because if you see here, this bond will break and this carbon has least number of hydrogen. There's only one hydrogen, this has two hydrogen. So with that, this has no hydrogen. This has no hydrogen, 1, 2, 3, 4 bond, and this is one hydrogen. So OH will come here. So you can use this. For this also, what we can do is, so this has to add here, so we can add this. Correct? In this case, OH will come here because this has less number of hydrogen. I can draw for you if you want. CH3, CH, double bond, CH2, CH2, CH3, 1, 2, sorry, it will be CH. Yeah. No, but if I use this, right, it's a headache. See, if I use this, my hydrogen can come here, OH can come here or here, any of these. So let's not use this actually. Let's not use this. Let's use this. That is CH2, double bond, CH, CH2, CH2, CH3. So in this case, if you compare these two, it has less hydrogen. So OH will come attached here. So don't use this, use this. Correct? So again, similar question. How will you synthesize the following alcohols from the proper alkene? So here also we have to somehow make this guy as a double bond, right? So if I use this or this, it's difficult. So OH can join here or here. So I have to give a double bond here. So if I give a double bond here, it will be fine. This is fine. So with this, if you see, this carbon has no hydrogen. So this is the carbon it will join. If you give something like this here, then it is a problem. Sorry. Something like this is a problem because in this case, OH can come here or here. But in this case, OH has to come here itself. Correct? Same thing, let's see for here. Here also, I have option of giving double bond here here or here. So if I give here, OH will come here because it will have least number of hydrogen. If I give here, both has equal probability. If I give this one, then OH will come here. So I have to give double bond somewhere here. Hope you understand what I'm trying to say. See, I'll take the example. So there are three possible options, right? Let me draw all three. So one option is this, double bond here. One option is this, double bond here. And one option is this, double bond here. So if you see here, this carbon has 0 hydrogens, right? This has 1 hydrogen. So OH will definitely join here. This is correct scenario for us. Let's see this. This carbon has 1, 2, 3, 4, 0 hydrogen. This also has 0 hydrogen. So OH can join here or here. This we can't take. Let's see this. This carbon has 0 hydrogen. This carbon has 1 hydrogen. This is also fine. So you can take any of these actually, because in any of these case, the OH will be added here. Correct. Let's take some conversions now. From propene to all. So I have propene to all. Pretty easy, just add H plus in presence of H2O. You get this propene to all. You have seen the mechanism, it goes for Markovnikov rule, correct? The next is benzyl chloride to benzyl alcohol. I have my benzyl chloride. I want to convert into benzyl alcohol. This is what required. I have to remove Cl with OH. I can treat this thing with NaOH, and then I can hydrolyze it. Let me try this. NaOH. What I get is CH2ONA, right? Plus I seal, obviously. And this, when I hydrolyze this, so this becomes CH2OH. This is one possible option. Okay. The next is we have to convert ethyl magnesium chloride to propane 1 all. So ethyl, the C2H5 MgCl, this is a Grignard reagent, to propane 1 all, that is C3H5OH. This is the conversion required. So since I have to increase the number of carbon by 1, I can react this guy. Let's see the conversion here, right? Plus HCOH. So in this case, what will happen? This gets negative charge, positive charge. This everything has negative charge, this has positive charge. So this C2H5 will attack this guy. So if you see the complex formed is HCO. Here I get MgCl, H, and here I get C2H5. This adduct, you put water to it, you get something like this. Correct? And this is nothing but my propane 1 all. The next is methyl magnesium bromide. So let me put a line here. Methyl magnesium bromide, that is CH3 is methyl, magnesium bromide, MgBr is magnesium bromide, to methyl propane to all, with it prop, right, prop to all, right, prop 2 and 2 methyl. Yeah, this is the compound I have to form from CH3 MgBr. So what I can do is I can take a ketone actually. If you see, if you add a double bond here and remove one thing from this, you get a ketone. So let's react this guy with ketone. CH3 CO CH3. Oxygen is electronegative, try to attract electron to itself, has negative charge, carbon slight positive charge. This everything here has slight negative charge and this side has slight positive charge. So these guys will attack this carbon. So the compound you get is, on O you get MgBr, and I have CH3, and I have CH3, and on this I get one CH3 here. And on this you add water, OMGBr becomes OH. So this is what I was looking for, correct? We have to tell the name of the reagents used in these reactions. So primary alcohol to carboxylic acid, directly from alcohol to carboxylic acid, that means a very strong reagent is required. So I need strong oxidant. I can use KMnO4. Alcohol to aldehyde, a weak oxidant is required, right? Because alcohol, primary alcohol to aldehyde, then acid. So only one step. So I can use PCC, pyridine chlorochromate. Bromination of phenol to tribromophenol. Let's see the reaction. This is phenol. I want 2,4,6 tribromophenol. This is 1, 2, 3, 4, 5, 6. So in this case, what I need is nothing but bromine water. Bromine water. So if I add bromine water to phenol, I'll get 2,4,6 tribromophenol. So again, you have to tell the reagents using the following reaction. Benzyl alcohol to benzoic acid. Again, alcohol to acid directly. I need a strong oxidant. And this can be KMnO4. Right? Dehydration of propane to all to propene. I know for this I need phosphoric acid, sulfuric acid, like that. And this is propane to all, 2 degree, 85% phosphoric acid. Is good. We have seen these reactions. Butane 1 on to butane to all. I need LiAlH4. And we have seen this kind of reaction where we convert ketone to alcohol. Correct? So we have to show how will I synthesis. So we have to show how will we synthesize the following. The first is 1-phenyl ethanol from a suitable alkene. So let's see what is 1-phenyl ethanol is. So 1-phenyl ethanol. So let me take a phenyl. At one position I have ethanol. That is CH and 1-phenyl ethanol. At one I have phenyl. In ethanol, since position is not given, it has to be at OH, first position. This is the compound they are looking for. I have to get it from a suitable alkene. So either I can have a double bond here or here. So let's see both the cases. If I have a double bond here, right? The other option is I have a double bond between these two carbons. CH2. So In this case, this carbon has 0 hydrogens, correct? So OH will add here. We told Markovnikov rule, the one which has less number of hydrogen, OH gets attached here. So we can't use this, because if we use this, OH will come here. We can't use this. If we use this, this has 1 hydrogen, this has 2 hydrogen. So OH will attach here. So obviously this is my starting material. So for first, the equation has to be this. CH double bond CH2. You add H plus and water. You get what you want. That is this guy. Done. Okay, let's try the second one. Second one is in blue. Cyclohexyl methanol using any alkyl halide by SN2 reaction. So what I want is this guy. Cyclohexyl methanol. Yeah, this is what I want. Right? Please note there is no double bond. All is cyclohexyl methanol. Using SN2 reactions, what I can do is here I can take CH2Cl instead of CH2OH here. And then I can treat with NaOH. And this NaOH will replace the Cl to become CH2OH. Correct. The next is pentane 1-ol using any suitable alkyl halide. So I'm looking for what? Pentane 1, 2, 3, 4, 5, 1-ol. So at 1 I have OH using any suitable alkyl halide. So let me take pentyl chloride itself, and same thing we can add NaOH here. So this OH minus will replace chlorine to get this. Pretty easy. Thank you. Visit our website examfear.com to watch more and more quality educational videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.